All right. Have a good day, everyone. This is a lecture video presentation talking about measures of variability or dispersion. It is important for us to know these particular concepts in statistics in research, since it is a great help for us researchers to at least identify or to check the data that we are having in our research study with respect to its variability or variances. Okay, so when we say variability or dispersion, this is a measure of average distance of each observation from the center of the distribution. Okay, they measure the heterogeneity, homogeneity of a particular group. It is where we can be able to look if our data is uniform, okay, consistent or inconsistent, or maybe stable. All right, so it is a big help for us researchers to be able for us to know the nature of this data that we have collected from our respondent with regards to its stability, uniformity, consistency, and among others. We can also say it is the agreement or disagreement of raters. Okay, so when we say variability, the opposite is dispersion. Okay, so when we say dispersion, we will be having a small value of variability. So when we have a small value of variability, it means the data is clustered closely around the mean. I repeat, the data is clustered closely around the mean. We can also say it is more homogeneous as compared to the other data, other set of data. We can also say the data is less varied as compared to the other. It is also considered as a more consistent. So all of this, okay, all of these characteristics are synonymous from each other, okay? And lastly, more uniformly distributed. So this is the meaning when we have a small value of variability, okay? These are the following tools that we can have, that we can utilize when we want to check the variability of our data gathered from our respondents. We can have the range, which is considered as the least reliable tool among these four measures of variability. Okay, it is by simply getting the highest and the difference between the highest and lowest value of measurement. Okay, however, it only concentrates on the highest and the lowest values. So that's why we experts consider this as the least reliable tool of variability. Another one is the mean absolute deviation. The third is variance. When we say variance, it is often given by the symbol sigma square. Okay, sigma square. So that will be a variance. And the last one is the standard deviation, which can be defined as the square root. Okay, it is the square root of the variance or the square root of the sigma square. So if we take the square root of the sigma square and simplify it, we'll be having the sigma itself. Okay, so standard deviation can be symbolized as the sigma, as measures of center of variability. So going back to the range, there are actually two types of range that we can use or that we can have. We can have the exclusive range, okay? We denote it as RE. So when we define exclusive range, this is the difference between the highest value and the lowest value, as what I'm saying a while back. So the formula is given by RE is equal to HL, where RE is the exclusive range, and your HL, H will refer to the highest value, and L will refer to the lowest value of measurement. Then the second type of range is the inclusive range, or the RI. Okay, it is the difference between the upper real limit of the interval containing the highest observation, or the HU, and the lower limit of the interval containing the lowest observation, or the Li. So it will be given by the formula R sub or Ri is equal to HU minus Li, where Ri is the inclusive range, and your HU will be your highest observation. Your Li will be your lowest observation in the limits. Okay? Note that in range, it does not provide any information with regards to individual observations. It only gives information on the two extreme values, which are the highest and the lowest values. So wala tayong pakialam in all the other members of the group. Basta ang gusto natin, malaman natin who got the highest, who got the lowest, and if we take the difference between the highest, yun na lang. That will be the information that will be taken from the value of the range. Okay? So let's have an example for this. Let's say we need to find the range of the two given data set. We have the mathematics achievement and the science achievement. Under mathematics achievement, we have the following scores: 7, 9, 11, 8, 13, 19, 15, 5, 8, and 10. While under science achievement, we have 10, 14, 14, 11, 15, 16, 16, 14, 12, and 13. Okay? So in order for us to find the ranges of the two given data sets, we need to identify the highest values and the lowest values of the two given data sets. So under mathematics achievement, we have the lowest value to be 5, while the highest value to be 19. So if we will subtract the highest and the lowest value under mathematics achievement, that will give you 14. Okay? So the range of the mathematics achievement is equal to 14. While in the science achievement, the lowest value is 10, while the highest value is 16. Okay? So if we will subtract the highest value and the lowest value, it will give you 16 minus 10, and that will be equal to 6. So as compared to the mathematics achievement having a range of 14 to science achievement having a range of 6, so which between these two is considered to be more uniform, okay, more consistent, more homogeneous from the other? So it will be the lesser, okay, it will be the lesser value for the range. So therefore, students who took the science achievement are more consistent as compared to those students who got or who took mathematics achievement, since the value of the range in the science achievement is lesser than as compared to the range under the mathematics achievement. So this is all about the range, okay, in as one of the measures of variability or dispersion. Okay, so let's proceed to the next one. This is the mean average deviation. We can have a formula for ungroup data for this mean absolute or average deviation. We can also have another set of formula for group data. All right. So the first formula presented, that will be the mean absolute deviation for ungroup data. It is given by the quantity, the summation of the absolute value of x minus x bar all over 10, where the absolute value of x minus x bar is the absolute value of the deviation of the x sub I from the mean. All right. So later on, I'll be presenting to you a dummy table, which will be our guide to come up with the value of the numerator of that particular formula for ungroup data. While for group data, we will be utilizing the second formula presented below. Okay, it is given by the summation of the frequency multiplied by the absolute value of x minus x bar all over n. where the product of the frequency and the absolute value of x minus x bar is the product of the frequency and the absolute value of the deviation of x sub I from the mean. Our x sub I here is our class mark. All right? So this will be the two possible formulae that we can utilize when we are computing on the mean average deviation. It is whether for ungroup data and group data. This will now be the dummy table. This will be our reference guide to come up with the value of the summation of the absolute value x minus x bar. Okay, we need to list all the values of your x variable. These are your raw data. This is considered as ungroup data. Okay, and we need to find the mean of that raw data that will be in the second column. You list the mean to every raw data, to every value of x. Then subtract the x and the mean. That will now be the third column. Then since we are getting the absolute value, we will concentrate on the third column. It is by simply converting all values in the third column into its absolute value. Okay, so all of these values will become positive later on. If you will get the sum of this fourth column, which is the absolute value of the difference between the x and the x bar, it will now give you the numerator in the given formula a while back, which is the summation of the absolute value minus x bar. Alright? And your small letter n is the number of elements. It is the number of observation in your given x variable. So this will be your dummy table for you to be able to know or to come up or derive with the value of the variables given in the formula for the MAD for ungroup data. Okay? Now for group data, sorry for that. For group data, we will be having intervals, okay? Intervals, frequency, we need to identify the class mark. We will subtract the class mark will serve as your x. We will compute for the mean. We subtract the class mark with the mean, okay? We get the absolute value, we get the absolute value, then we will multiply it to the frequency. The product of the frequency and the product of the frequency and the absolute value of the class mark and the mean will now be summed up, and that will be the value of the numerator in the group data. And for n, that will be the total number of frequency. So this is the dummy table. Yun yung dummy table, pero unfortunately hindi nyo mabibview kasi siguro sa mga formula na binigay ko or yung mga symbols na binigay ko hindi kayang i-present dito sa PowerPoint ni Google. Alright? So kaya hindi siya nag-available. Basta ganon, yung first column dito sa MAD for group data, we have the interval. Second column will be the frequency. Third column will be the class mark. Fourth column will be the mean. List the mean to every class mark. Then subtract class mark and the mean. After that will be the fifth column. For the sixth column, we will be having the product of the frequency and the fifth column. Okay, then sum up, that will now be the summation of the frequency multiplied by the absolute value of x sub I minus x bar. And the end value will be the total number of frequency. Okay, so that is the math. For the variance, we will have another set of formulae. Okay, one will be for ungroup data and the other will be good for group data. Okay. However, in the ungroup data, it would depend on how we treat the data. Okay, so these are the two possible formulae for the ungroup data. Okay, whether we will treat the data as a sample or whether we will treat the data as a population. So when we are computing for the variance for ungroup data and treating the data, okay, and treating the data as a sample, okay, as a sample only, we will be referring it to the lower formula. While if we are treating the data as a population, we will be using the formula on the upper portion. Why? Because when we are treating the data as a population, we are using the symbol mu as the symbol for the mean, and we are using capital letter N, okay, as the population or total number of population. Under the sample, we are utilizing x sub bar or as the value of your mean. Since we are treating it as sample, we will be having n minus 1 in the denominator. And this n minus 1 will refer to as the degrees of freedom. So what is the use of having this n minus 1 when treating the data as sample? Alright? So since we are treating the data as sample, and this sample represents the population. So if we subtract 1 on that particular sample, it's just like we are trying to lessen a possible error that will occur on that particular sample. So that is the degrees of freedom. And the degrees of freedom is given by n minus 1. Okay? So this will, the upper portion will be a formula good for ungroup data, treating the data as a population, while the lower formula is a formula to be used when you are treating the data as a sample for ungroup data. Okay? So this will be the dummy table. Okay? This will be the dummy table for the variance of ungroup data. Okay, we need to list all the observations as what we did in the mean absolute deviation. We list all the scores or maybe the data. Okay, yung capital letter N that will denote, yung L natin that will denote the total number of elements or observation on your X variable. Then the second column will be the mean. Okay, we need to compute for the mean of that X variable. Ano yung kanyang mean? We can utilize the arithmetic mean in that case. Then for the third column, we will now subtract, okay, x and the mean, and that will give that is given by x minus x bar, treating the data as sample, or x minus the mu, treating the data as sample. After subtracting, we need to get the square. Okay, that will be for the fourth column. Since we are in the numerator, we are getting the square of the difference of the observation and the mean. So we'll be having a portion on this table as the presentation of the square of the difference between the x and the x bar, or the observation and the mean. That will be for the fourth column. After getting the square, we will sum up all these values, and that will be the value of the summation of x minus x bar square. And this value will now be the numerator in this formula. Okay? And your n, of course, your n is the total number of observations in the given data. So this is your guide. This is a table to facilitate the computation of the variance for ungroup data. Okay? Let's proceed to the group data. Again, it's up to us. How do we treat the data that we have gathered? Are we treating it as a population, or are we treating it as a sample? So if we have treated, or if we treated the data as a population, we will be utilizing the upper formula. While if we are treating the data as a sample only, then we will utilize the lower part or lower formula. Again, we will subtract 1 from n, and that will be the degrees of freedom, since we are only giving or treating the data as a sample. So to at least eliminate possible error as of this sample to represent the population, so we need to less 1 on that particular n. So this is what we call the degrees of freedom. Okay, so the difference of the variance for group data for population and sample is the denominator. Alright? The denominator. So, again, hindi nag-work ng aking dummy table for the variance. So, ang tandaan ninyo, yung first column ng dummy table will be the intervals. Yung second column will be the frequencies. Okay? Will be the frequencies. And yung third column will be the class mark. Okay? Yung fourth column natin will be the difference between the class mark and the mean. So we need to compute for the mean. For the fifth column, we need to get the square of the differences. X minus x bar square. Okay? Then the sixth column will be the product of the frequency and this squared difference. Okay? And you need to get the total of that sixth column, and that will now be the numerator in the formula. It is the summation of f multiplied by x sub I minus x bar square. Okay? Then yung value ng n natin will be the total number of frequency. If you treat it as population, then just use n. If you treat the data as a sample, then you subtract 1 from the total number of frequency. So this is the variance for group data. Now for the standard deviation, it is now very easy to do, since the definition of the standard deviation is just the square root of the variance. So after finding the variance, just take the square root. That will now be the value of the standard deviation. Okay, that will now be the value of the standard deviation. I repeat, after knowing the value of the variance, just get the square root, and that will now be the value of the standard deviation. Okay, so it is given by, so this will be the two sets of formulae for the standard deviation for ungroup data. Magkakaroon ka ngayon na ng square root. And this will also be the other set of formulae for the standard deviation for group data. Okay? So this will be a problem exercise. You need to find the range, mode, standard deviation, and the variance of this particular data set. This is ungroup. And for group data, you need to utilize this problem or this data. Again, you will find for the range, you find for the mode, variance, and standard deviation. So thank you once again. If you have questions, just post your questions in the comment part, and I'll be answering all your queries and questions. Thank you, and have a good day.